Hello folks, we're back to the Edison battery iron oxide tutorial again. I've changed that a little bit here. I've decided not to use the Fe2O3 to make my hydroxides. It's just too much conversion, but it's come out with some nice stuff here I can use for something else. The easier way to make the iron chloride or ferrous chloride is steel wool pads. You can see at the bottom here it's just beautiful mass of crystals and then solution, which is highly concentrated in here. And if you notice the vent hole on the top, and right here I have a vent on the wall with a tube that goes outside. Now when you make this, you put in a half a liter of hydrochloric acid, 31.45% is what I was using right here, and I put in grade 000 steel wool pads, which are not steel, they're actually iron. They're low carbon iron that's been hardened through a wire drawn process. If they use steel wire, the steel wire wouldn't shred like this, it would chip. So that's steel wool is just a name that's been adopted to it. But anyway, those small pads dissolved 11 in about 20 minutes. I put 13 in there, and I have about 1.5 left, so it'll finish neutralizing acid in a couple of days. So that's that part. To make a hydroxide out of it, you put in sodium hydroxide slowly because it puts off a lot of heat, and you get this blue crystalline stuff here, which I hadn't purified yet. Just wash it. It has some salt in it from the reaction, put a little extra sodium hydroxide, and has some dab of unreacted stuff, probably a little silicon, some manganese and stuff, which will wash out. That's in the iron. Okay, this is a nickel chloride I made a while back. That was one of the tutorial. Nice blue-green liquid. Has a lot of stuff in there right now. That's heavy. It feels like it's got a brick in it. And after you react it with the sodium hydroxide, you'll get sodium chloride, and you get nickel hydroxide. Which is a Nicholas hydroxide, and this is ferrous. Nicholas and ferrous is what you want. When they manufacture the cells, they have plates, but the plates are actually just a substrate to hold little pockets of the chemicals, which the nickel is a negative and the iron is a positive electrode, I believe. And when you do the nickel, here's what you get. You get a nice, looks like a peanut butter, looks like a lime peanut butter kind of stuff, and that's a nickel hydroxide. Okay, my plan for the battery, what I'm going to do to start out with, I'm going to make a couple little wire cylinders, get a glass container, has this one here, it's got the Fe2O3 in it, and make a couple pockets. What I want to do is take this coarse steel wool, keep one iron, and take another one and nickel plate it. I got a Watts bath here I want to plate the steel wool pad with to make a nickel substrate to hold the chemical. So I'm going to make a spot welder up, and I got some wire, and make the wire hoops. Make one wire hoop to go in the center of the jar here. Hook wires to the nickel steel wool pad in a couple spots, some nickel plated wires, and completely immerse this into the nickel hydroxide here, and make that to be the electrode, and pack that very tightly into the center one. Then take the center electrode or plate, whatever you want to call it, and put a couple layers of fiberglass cloth over it, just to insulate it from the outside one. This is porous. The ions will go right through it, no problem at all. Okay, on the outside of that, on the area left here, I'm going to put an outside hoop or wire, that's iron, connect it up, and do the same thing with this, except not nickel plated. Put it in the hydroxide solution and pack around it very tight, and run the wires through it, put my electrolyte in it, 20% solution of potassium hydroxide if I can find some. Anyway, so when you buy the batteries, that's how they come. They have the pockets that's got the iron hydroxide, the nickel hydroxide in the pockets, which represents a dead battery. Through the process, it turns the iron hydroxide back to basic iron, which will be porous iron, when it loses the OH factor out of it. It'll transfer the OH over to the here from Nicholas to nickelic hydroxide, and that's how the battery charges. So basically that's what we got. That's my process. So I'm going to get off my rear end and I guess make a spot welder. And like I say, if you're going to do this, put a couple of little steel wool pads in at a time. This works real fast, real hot, and it puts off large volumes, very large volumes of hydrogen gas. I'm talking about lots of hydrogen gas. You probably blow up a blimp with it for 20 minutes. And also puts off hydrogen sulfide, which really smells bad and it's pretty toxic, and some HCl gas. So when you do that, just be careful. vent it outside, and it'll work. It'll work overnight. But let it sit for a couple days, and what happens is it condenses down. And you can put it in the freezer overnight and double the amount of crystals you get out the first time. They'll get large, huge crystals in it. You can dump the liquid off, scrape out the crystals, and take the liquid, filter it, get all the iron particles out, and put it back in the freezer and get some more liquid out of it. And once you do that, the liquid still contains a whole bunch of the chemical. And when you go to put it back together, because the chemical will react with the hydroxide just as well as this here does. You have to dilute this with water, because these crystals have to be diluted with water before you put the hydroxide in it. Mix it in slowly, like I did with this right here. Put in a little bit of lye, because this got hot enough to bust the jar. And work it down, and it'll make this green paste. And the suspension will start going up the jar. It'll go up, and you'll see a little line of the light green color here that's still clear. That means it hasn't all reacted. So keep adding just a few grams of the hydroxide, and keep shaking it until it settles overnight. And then once it settles, you won't have any more of the clear on top. And it's pretty much reacted. I'll go ahead and put another gram in, shake it up, and let it sit overnight. That way you won't have any waste. Then just filter it, and when you filter it, if everything's worked, the filter liquid will be crystal clear. It'll be salt water. So basically what you'll have is salt water with some nickel in it. Now keep in mind, nickel is toxic. It can be absorbed through your skin and give you all kind of skin problems. The iron hydroxide is just pretty much a little bit caustic. It can give you some burns. It'll stain anything. It'll stain sunshine. So be careful. And I'm going to start posting this on my Yahoo group site, which is edsworkshop at yahoogroups.com, and that's spelled EDSWORKSHP at yahoogroups.com. If you want to log on to my group, it's fine. It's a public group. Just drop me a note. Let me know what you're interested in. And if anybody has any potassium hydroxide they'd love to send me, just email my group. Get on there, and I'll be happy to cover you for it, or send you something I got. But I need about a pound or two. 2-pound bottle like this would be great, because it's hard to get here in town. You almost got to be the governor to buy cold beer here for some reason. I don't know what the deal is. But anyway, that's my Edison battery tutorial today, and next time I post one, hopefully I'll have a spot welder built and some wire hoops. A spot welder built, and a couple wire hoops, and just whatever, and we'll see, and we'll go from there. And but all the chemicals are working out fine. And you can buy these chemicals. You can buy most of these chemicals from a place that does ceramic. They sell these chemicals to make ceramic coatings and stuff with. All this stuff here you can buy. I just have the chemicals, and I just like making stuff like this, just to mess around. But anyway, I have a good new year, and I hope to see some of you guys on my group here before too long. Thank you now.